right. Good morning, everyone. Let's get started here. If you're watching online, make sure you have your cameras on. Okay, so last class period, we basically finished that script using the NASS data where we're looking at some different summaries. I do want to go back to that just because before we move on to the next script, I want to talk a little bit about that previous script, the NASS tabular data that we're working with. So I'm just going to navigate to that folder. You should have a similar one. I'm going to launch that 03 NASS R project. Make sure if you don't have that R Studio window open for that project, make sure you do that. Okay, so yes.
Just say I've got a question just real quick, kind of before we get started.
Yes.
So the end of last week, we output that data as a CSV. So I saved that on my laptop and like it saved, it works, everything's there. But when I opened it, it opened as an Excel file. And there's just a little like warning across the top that says I could like possible data loss. Is that an issue to worry about, or is that just something that it's going to say?
No, I'm just gonna say that. So whenever we save a CSV, I guess if you have Excel installed on your computer, it's going to open that with an Excel, with Excel itself, even though it is a CSV. And it just says that mostly because CSV, like if you open that CSV file and opens on your Excel, like as an Excel sheet, looking like that at least, like if you color cells or if you add different things that in Excel would work in a CSV file, once you save it, it's not going to save. So you're going to, if you do any changes in Excel to that CSV file that are related to color or formulas or anything that you would do in an actual Excel file, a CSV file is not going to save those. So it's just kind of telling you that if you do those changes, they're not going to be saved, but we're not going to be making those changes ourselves. Yeah, so that should not be an issue.
Correct. Thank you.
Yeah. All right. So before we really move on to our next script, what I wanted to show you here, which is one of the things I really think it's nice about quarto files. Remember, we're using a quarto, a .qmd file, is that if you come all the way to the top, and if you just like if all the chunks you had below, if they are all working properly, if you did not leave any bugs behind or anything like that, if you come here on this when you have your quarto file, there is this render button. If you push that render button, it's basically going to compile all of your code and it's going to create an output. The default style of that output is a HTML file, which for me, so it worked all right. I had no chunk of code that was giving me errors. So we went through nicely and it rendered my output here on the side. And before I really open that, I just want to show you some features of Quarto and also R Markdown for that matter that I think are really handy. So if you notice here, I believe we talked about YAML, which is this first part of the script here, that every script has at least some information about that script within the YAML part of it. And the YAML is basically these 3 dashes, and then like starting at those 3 dashes and ending on these 3 dashes. So all this information here is pretty straightforward. So we see there is a title that we put there that comes out as the title of this rendered file on the HTML output. You can have a subtitle. You can also see how that translates over. I'm just changing some options here of the formatting. So I'm saying that I want the code to fold equals true. I'll show you that in a second what I mean by that. I said that I want a table of contents. So that's also going to appear in our HTML. We're going to see that shortly. And I'm also setting my theme, which there's a list of themes. If you search on the Quarto website, there's a lot of really great resources there. We're not going to go there right now, but I just wanted to let you know in case you do want to, customize things differently. So we could change to any of these themes. And before we do that, I just want to show you the actual output. And also to remind you that when you're using Quarto or R Markdown, outside of the chunk, whenever you use the hashtags, that it identifies a heading, right? So one hashtag is heading level 1, 2 hashtags is heading level 2. And as you're doing that, is building on your script this table of contents, but also once you render it, it's going to appear on your render output. So I just want to come to the side now and open this on my browser so you can see how that looks like right now. So we have the title, subtitle, we have this intro that I wrote a little bit. This is a hyperlink, right? So if I click here, it's going to take me to the website. So there are ways that you can embed hyperlinks within your Quarto files as well. When I told you that it was the fold code equals true, it basically means that your code is here, but it's basically folded, right? So it's not showing the code every time. Sometimes you may want to show your code, sometimes you may not. I think I mentioned this earlier, a lot of times I use Quarto to write reports, and sometimes the person that is receiving the report does not care or understand R. I just hide the code completely because that's not going to matter to them. But if they do understand and they want to see how you made things, I leave the code and especially leave it folded so they have the option of seeing it if they want. It's going to be there. Also, you see that on the right-hand side, it already gives you this table of contents, so you can really navigate through the script very easily by doing that. And you can also see how if you write any comments, it's going to appear there. It gives you those headings that we created. And also any tables or figures that we created appear here as well. So that's all, by default, is giving you that structure. So I think it's, it doesn't take a lot to create a Quarto file that is very well organized. And if you do that, you really benefit from this, added extra functionality of being able to produce an HTML report very easily. You can also choose other formats. So you can choose a Word file or a PDF as your output file type. The default is HTML. So I just wanted to show you that. And then before we move on, just very quickly here, so I left here the names of some of the different themes that you can choose. I'm just going to take one of those. So the blue one that we're seeing is called Cerulean. I'm just going to change to maybe let's do, I don't know, Sketchy is the name of one of them. Just so you see how that would be a very easy way to quickly change how your report looks like. And you can explore these on your own if you do want to look for something that, may be more aligned with the way that you would like to have that. So you see, I just re-rendered under the Sketchy theme. And then if you open up, it just looks a little bit more like handwritten perhaps, but still, everything else is the same. So just wanted to show you all this because when you do the mini project, you're going to have to turn in your script, or not your script, but you're going to have to turn in to me your HTML render report. So I just wanted to expose you to these features, I guess. And remember, if you have any pieces of code that are not working or that you have bugs in them, then the report's probably not going to render. It's going to give you an error and it's not going to give you an HTML output. So just keep that in mind. So that probably means make sure you comment off your install.packages. I've noticed that if I have the function view to show me, like if I'm doing analysis and I have this function called view, which we used before to like view a data set as a tab on the side. If you have those active, that may give you some errors as well. Those are just some pointers here. Also, if we come back here on the Files tab and you go to where the script is, so that should be inside of the code folder. Now there is an HTML file, so I'm just gonna increase here so you can see. There's an HTML file that is the rendered version of your report. So if you click on this, you can open that in your browser, which is the same thing as what I just showed you, but that is where the file lives in your folder structure. So if you once you render it, it's going to create that HTML ready for you, and it's going to save on the same folder where your code is. So if I ask you send me your HTML, you would send me your HTML, not your QMD. Okay, so that's just what I wanted to show you before we move on to our next script. So I have uploaded last week, actually, the script for today's exercise. So I want to invite you to go to GitHub and download that script. Yep.
I'm trying to render it and it just keeps saying execution.
Okay, let me take a look.
I'm not sure if you're doing something wrong on this.
Yeah, maybe something like something's going on. Okay, so I think it's because of that library. Did you go back to that script? It's yeah, so you just want to deactivate that. You look in there and now. See.
Okay.
Yeah. Yeah, that's a good Yeah, so if you have, again, any piece of your code that is not working on the chunks when you run that chunk, that whatever it is that's going on, that's gonna keep it from rendering. So one good example here is, so this package dlooker is not available anymore. So make sure that so we were not able to install it, meaning that we cannot load it, right? Because it's not installed. So if you have this line of code active, you're gonna need to comment that off, or even just delete that line of code for dlooker. And so that would allow the code to keep going. Let me take one moment here and ask, well, let me ask this way. Is anyone having issues to render your script at this point?
I tried running mine and Tifton and it said it got to 98% and then just quit.
Does it,
Now, in the code folder, there's a file with HTMLs, but it's not one continuous thing. It's just like pictures of all the graphs.
okay. I think there's probably something going on. I can, well, let me ask, is anyone else having that same issue? Yes, Niva? Mm-hmm. Okay, so maybe there's something happening at the export. So let's go to that chunk and just take a look at that. This is what I have for mine. And so we had this situation where if you did not name your folders exactly like mine, then the path that you may be using on your side would be different than mine, right? So the way that I got to this, and every time that we're either reading data or exporting data from into and from our, what I always do is I have the double quotation marks. So right now I am on the code folder. I know that because if I hit tab, I can see where I am. But when I get outside of there, so we do .. and if you hit tab again, you should navigate to whatever output folder you named. So in my case, it's lowercase output. If you follow the same naming convention as me, then yours would be as well. And then here we just gave it a name. So it's just /soybeans _NASS _process.csv. If I run this, well, if I just run this at this point without running everything above, it's not going to work. But basically, if I were to run the script until this point, or at least until creating soy W, it should work. So let me just run that just to test on my side. Yeah, so it did work on my side. Neva, you still having issues? Okay, let me double check, and then and I'll be right back to double check what's going on in Tifton as well. Let's see here. So come on into the switch out and just put it around above it. This. See if that goes through. Okay, so that works. Let's come here. Nope, I don't know if that would get. I think it would still. For some reason. Maybe if you try to close the file, maybe that's it. And then if that's the case, I'll make sure. Let me just run this piece of code here so that works. Okay, that was it. Yeah, that was in her case. Interesting. I never noticed that. Okay, so we just found out maybe the culprit, at least here. So the way that you can troubleshoot it to see if it is that last piece of code that's giving you issues would be, so if you come in your script, you come on the outline. So if you're not seeing the outline, just need to click on that button and you go on the soy W script. We actually want to run everything above it, including it. So if you come to this chunk, go to the next chunk actually and hit this button here, which is the run all chunks above. So if you run this, it's going to run everything and stop right here, which should create the soy W object on your environment. Once you do that, you can just skip everything else because then we're not creating any more objects. We're just exploring with graphs and tables. So you can just skip all that, go all the way to the end, and then run just that right CSV. If that doesn't work for you for some reason, it is possible, there's a couple of things that could be going on. One of them is your path was not correctly set up. And the other one, which we just found out here in Athens, is if you do have the soybeans NASS process.csv file opened, like you actually have it open on your computer, then that's gonna keep the right CSV from running because it cannot write again since the file is open on your computer. So we just need to go ahead and close the Excel window where you have this CSV open and then try again, and that should work. Yes, Rolando.
So you go to line 225, right, and run everything there. That upper right tab.
You mean you came here and you ran everything? Is that what you're saying?
Yeah.
Yeah, you can do that as well. You may just take an extra second there, but you can do that. Did that fix the issue of you guys in Tiffany?
Yeah, mine worked that time.
Awesome. Rolando, are you still having issues?
It's running.
Okay. So while we wait for that to run on Rolando's side, I just want to tell everyone, if you have not yet, please go to GitHub and download the newest version. We have a new partial script there that we're going to be using. So you can start at least downloading from the GitHub, and then we'll follow up on that shortly here. Rolando, did that work?
Yes.
Awesome, awesome. All right. Yeah, so I just wanted to show everyone how you would render your Quarto script and how that will look like in the end, because our mini project's going to be based on, you're going to send me your HTMLs. So no QMD files, you will send me your HTMLs. All right, so what I want to do next is, if you want, you can save the script and just close it, because we're not going to be using this script anymore. But then you would need to go to the GitHub for the class, which is github.com/LeoMBastos/2024 PPA, and just download it. If you are taking my other class, you can actually just do a git pull. But if you're not taking my other class, don't worry about what I just said. You can just go ahead and download that zip. So what we would do then is you can move this downloaded GitHub repo to the overall folder for this class, which would be looking kind of like this, where you would have that 2024_PPA_main on your side. And then if you go in there and you go under 04 class code, I want you to copy that 0126 NASS spatial partial. So copy that. And then go back to the main class folder where you can see 03 NASS. You go inside 03 NASS and paste the code inside of the code folder. All right. So just a reminder, never use the file straight out of the GitHub repo, because that's not what we want. We just want to use GitHub to get the files, and then you copy that file into your own project folder, which in today's exercise is still the 03 NASS project folder.
So the NASS spatial.
Spatial, yeah, spatial partial. So once you've done that, you know, we're still within the 03 NASS project. If you happen to have closed your window, make sure you reopen that 03 NASS or proj. And once you do that, so you should be seeing the 03 NASS on top. If you are not, make sure you do this, because otherwise you're going to have issues reading data and exporting files. And then once you're there, if you come on the Files tab, you can click on the R blue button to take you to the main folder of this project. And then you go click on the code folder and then click on the script that you just moved there. So we could launch that script up here. All right, if anyone still needs more time to get to this point, or you had some issues or you have questions, let me know. I'm just gonna give a moment here.
So go to data and code and launch 126.
Yeah, so if you are in the right project, so 03 NASS, you would come on the Files tab and then click on Code and then launch that 0126 NASS spatial partial.
Okay.
All right, was anyone not able to get to this point? All right, I don't hear anything, so I'm gonna start moving on here. Okay, so really this second script on the same exercise or the same project, the 03 NASS, is just so we can explore our data, but now in a geospatial context. This is going to be important because even though this in itself is not precision ag yet, but it has some very important concepts of geospatial data in R that I wanted you all to be familiar with before we get into our field level precision ag data. That comes after this exercise. Okay, so if you remember, we downloaded that NASS data for soybeans production historically for at the county level in Georgia. You have a question? And we already processed that. We created that soy.w object on the previous script, and we use tables and plots to explore that and answer some questions, right? But now I want to visualize this, see this in space. That's what we're going to be doing here. I left you a few lines of code of packages you're going to have to install. So what you can do is just go remove the hashtag to uncommented. Do not run all the chunk, just run this line of code for install packages. So this USA boundaries is a package that has the shape files or the vector files for US boundaries. So that includes the whole US, states boundaries, county boundaries. I believe it may even have like zip code boundaries and others, but we're really using this to get the state and county boundaries. So if you go ahead and install this, I remember last semester, if you run this and you get a message saying something, you may actually have to install another package that I think is called USA boundaries data. If you get that message on your console, then you can go ahead and do that. If I run this on my side, it doesn't give me that message anymore because I have already installed it. But if it does give you that message, you know, you may need to install.
I'm getting that message.
Yeah, we are too in Tipton, and Tipton, it says the package USA boundaries is not available for this version of R.
And USA boundaries data would work either, Trev.
Can you repeat
Yeah,
that
this
last part? USA boundaries data?
Yeah, if it's just that, then I couldn't get it to work either.
You cannot get it to work?
It says it's not available for this version of R.
Let me try on my side. Okay. Yeah, this is, let me just double check that here. I think they may have changed something since last semester. So let me see what this tells us. So, you know, if you can just go on that page. Let's see, what is this telling me? Let me try installing USA boundaries package in our installation. Okay, so this is not working. So maybe let's try to install the development. So here's I guess is an interesting concept for any programming language really. So in R, if you're installing a package using the install.packages function, then you're basically installing it from what's called CRAN, which is the repository of packages that are submitted to R and are accepted by R to be available. So they go through a lot of checks, right? That R keeps them, makes sure that only packages that work are accepted into CRAN. So it's almost thinking of like your app store, right? So if you go to your Apple or Android app store, those packages, those apps have been submitted, accepted, went through validation, and they get through the store. However, there is another way to install packages that is through GitHub. So if you are a package developer, you may make your package available on GitHub first and then submit it to CRAN. So there is a way that we can install these packages straight out of GitHub. And I just, so here's the code for that. If you are already getting familiar with this, you may realize that to do this, to install directly from GitHub, we need a package called remotes. I don't think you have that package installed yet. So we can just go ahead and do a install.packages, open and close quotation marks, and then remotes. So first we need to do that. If you are asked here if you want to restart prior, you can just say no. And then it's going to install that package for you. It should be straightforward. Once you have that package installed, let me just copy and paste this to you all on the chat. If you're here in person, yeah, you're gonna have to just copy that. But this is a function called install_GitHub that is coming from the remotes package. And this is just a path within GitHub to find that package. So ropenSci is the name of the username, USA boundaries is the name of the repository on GitHub. So let me get this on our chat. I noticed in the past that sometimes if I paste code in the chat of Zoom, the quotation marks, if you copy and paste that, it may come off weird on your side. Let me try on my side here. No, I think it actually worked. Yeah, so you can just copy from what I pasted there. And let's try and install this through this and see if we have any better luck there. Okay, I think, yes, someone online?
I think it worked for me.
Okay, so if it did work, what we would do then is if you come on the library USA boundaries, try to run that and see if that, but just that by itself, if it doesn't give you any error, it just lights green on the left side and it doesn't give you any errors, then it worked.
Not working there? Work it? You mind the library that USA boundaries data are installed? Yeah, you have to use a capital D. I didn't use that. It worked earlier.
So sorry, I couldn't quite get that. In Tifton, is it not working?
Well, it wants us to install the USA boundaries data, which it ends up working because you have to use a capital D, and I didn't have the capital D. So we can install that and make it work.
Okay. So if it is asking for you to install the USA boundaries data, you can just copy this and paste so you don't have to rewrite everything. And I think it's just, let me double check here on the.
Well, I could install it the regular way using install.packages.
Okay, that worked.
Yeah.
Nice.
Be a different code in the error messages that we try it and get the data to it. It's different.
And it worked? Okay.
Run green and that didn't show nothing. It's
Yeah,
running.
it works.
Okay, it's working.
Awesome. So it seems like it's working. The way that you can try to make sure it is working is if you come on the library USA boundaries and you run just that line of code, if it doesn't give you any errors, it's because you were successful in installing it. So you should be good. If you run that and it says you don't have it or gives you some type of error, then it's not working. Then you have to just revisit some of these steps here. What about here in Athens?
Right.
And there is data.
Send us. Is that working for you?
We needed boundary data also
You
as
guys-
well.
No? Okay. Cornelisa? Okay. Awesome. Yeah, this, you know, it's it took us a little bit of time just to troubleshoot this, but I think that's also, it's also a, you know, an interesting learning moment because you're gonna run into these issues when you start doing things on your own. So it's kind of nice to troubleshoot together and see how we would do it. And also this concept here of installing something from GitHub, I think it's a useful one for you to be exposed to. Okay, so I know Neva here is catching up online. Orlando, Kumar, the guys in Tifton, were you all able to get things going?
I think I get it at the end, and says done USA boundaries data. That's all I have. I think it installed.
Okay, so if you run the library USA boundaries, does that go through without giving you any errors?
Yeah.
Great. Awesome. I think everyone is on the same page. Neva, you need some help? Okay, all right. All right, so let's keep moving here. I do want to remind you that please make sure you comment off that remotes if you had it active. Also comment off the other install underscore GitHub, so those become inactive in your script. As if you recall, we only install things once. We don't have that active always in our script. So if you're able to successfully install USA boundaries and or USA boundaries data, the next couple of packages that we're going to have to install here is map view, so we can create maps that we can interact with, and also varieties. So we have a colorblind safe color scheme for our maps. So just go and comment off, or sorry, remove the comment, remove the hashtag from install.packages map view and run just that line of code. Do not hit the run all chunk. Just that line of code, you can go ahead and run it to install it. Once that goes through, we can add the comment back and then uncomment the install.packages varieties, install that one as well. And once that goes through, you can just comment it off again, so it becomes inactive in your script. I don't think those would give you any errors or issues, but if they do, let me know. And we're gonna know if they did or not once we start loading these packages here on the library function. So because it is the first time that we are using some of these packages, what I want to ask you to do is have your cursor first on tidyverse and run just that, right? If it becomes green on the side, then it was loaded. It means that you install properly. Then just keep going down the list one by one. DigiThemes, SF, USA boundaries, map view. And some of them may give you some messages, but as long as it doesn't become red on the side here, then you know it's loaded. So we can just keep going. You know, especially the SF package, it's one that we're going to be using geospatial data. And I'm just going to load it again just so you can see the message. It's not giving me a message the second time around, but it was giving me this message here, linking to geos, GDAL, proj. So this is just telling you that if you have ever used any geospatial software on your current computer previously, this could have been in Python, could have been QGIS, ArcGIS, anything that is GIS based, you probably have already installed these libraries on your computer. So geos, GDAL, and proj are not R specific, they are GIS related. So if you ever use any GIS on your computer, you would already have these. And if not, maybe SF already installed them for you when you installed the package SF. Okay, any issues? any questions at this point if you're stuck on code or something didn't go right? All right, I'm not hearing anything, so let's move on. So the next immediate thing we're going to be doing is reading data, right? So what we're going to be doing is reading the data that we actually exported as part of the previous script. So because that is a CSV file, we're going to give here the assignment symbol and use the function read_CSV. We're going to open and close quotation marks. If you hit tab right here, it's going to show you that you are in your code folder. So .. to get outside of it. We exported that CSV data from the previous script to the output folder. So you can go in there and then you should have the soybeans NASS processed in there. Right, so we can just go ahead and run that. So if you followed, the exercise of previous class, especially the wrangling step of it, if you follow along what we were doing live here, you should have 5,877 rows and 4 columns. If you have a fewer, less, or more, I wouldn't be too alarmed. If you have way too many more or less, then you're going to have to address that because something went wrong.
It's 5,800. I got 5,877 and 5.
And 5, that's okay. You probably just, you can compare it to mine. These are my four columns. Maybe when you did a select that you select another column, but as long as you have these, you should be good.
We have a column in X. The lady plus column.
X?
Yeah.
Okay, so you have X and then year, county. Okay, I'm not sure why that difference, but we don't have to worry about that. As long as you have the same or very similar number of rows and at least these 4 columns, you should be good. All right, anyone have any issues here that you want to ask? Okay, I don't hear anything, so I'm going to keep going. So notice how on file, this is a CSV, right? It's not a shape file. It's not anything like that. It is a CSV file. And once we bring it in, it's considered a tibble or a data frame. So at this point, this is not geospatial data yet. The thing here is, if you think about it, the only potentially geospatial column here is county, right? Because we know the name of the county. And even though in this data frame in front of us, there is no geospatial data, but we can use the name of the county to connect it to geospatial data through that name of the county. So that's what we're going to do next here. If you come to the next chunk, this on the left to the name of the object is going to be Georgia_CO. So Georgia counties. I want to give it the assignment symbol. And then we have this function called US_counties, which if you notice is coming from that USA boundaries data set. So this USA boundaries data set has other functions that you can retrieve all the shape files for the US, all states, different political level boundaries. We're going to do that for the counties first. So here it has this argument called states. I'm just going to open and close quotation marks and say Georgia with uppercase G. If we run this, and if you were successful in installing and loading the USA boundaries data, you should now have this object called GA_CO on your environment. If we go ahead and check the class we see that it is an SF object in a data frame. So if you recall from the lecture that that I wasn't present, that you watched online, SF is the name of the package and also the name of the objects in R that we're going to be using to handle vector data. Right, so vector data is data related to, you can kind of think of it, when you think of a shapefile, that is vector geospatial data. Right, so if I just print here, Georgia Crow, it's gonna give us, some information. So he's saying it's a simple feature, an SF object with 159 features, right? So this would be the different rows. So one row for each one of the counties and 15 fields. So it has state FP, county FP. It has some other information there. It has, notice how it has a column called name, right? And this is the actual name of that county. And notice how it is written here, right? So it is uppercase, only the first letter, and then the rest is lowercase. This is going to be important in a second here, and that's why I'm pointing out. And then the last column here is a multi-polygon column called geometry. So the column name is geometry, and this is where the geospatial information lives. So this is where, when we make maps, this geometry for each one of the counties is what's going to put the county in space and give it its shape in a map. Okay, so let's just go ahead and do a very quick plot here. One of the cool things about SF objects to work with geospatial vector data is that it plays very nicely with ggplot. So let's begin a ggplot. We're going to say data equals GA_CO. And then we're going to leave it that, get out of that ggplot, add a plus, hit return. And let's ask for a geom_SF. Now notice how if I am making a plot, or in this case, a map using a SF object, I will use this geom_SF because it handles that file type directly. Oop, I guess I forgot to, no, yeah, CO. So you should now be seeing something like this, where you have your X and Y are latitude and longitude, and you're seeing the county shapefiles in R. Notice how if you are using geom_SF, you don't even have to say what is X, what is Y, because it is already extracting that information straight out of that geometry column that this GACO object has, which is related to it being an SF object. Okay, was everyone able to get to this point? Or maybe was someone unable to get to this point?
I wasn't able to.
Okay, what is going on your side?
It is showing that US boundaries package needs to be installed. Even though I have done that, it is again showing me that.
Okay, so have you tried doing the USA boundaries data?
Yeah. Okay, should I share my screen?
So I think that we may, I mean, if that's the error is giving you, we're just gonna have to try to install it a few different ways. I can help you. I think maybe we can, I think it's gonna be easier if I help you out after class on 101, if that's okay. And then we can make
Yes.
sure. All right. Okay, so besides Kumar, was everyone else able to, or was someone unable to recreate this map here? Yes. Not working?
Install USA boundaries data, but
It's still not working? Okay, so Neva and Kumar, let's connect after class, and I want to help you to troubleshoot on your side. Okay, so if we come to the next chunk here, I believe I already left you this. So, you know, I just want to walk you through what's going on here. So I'm creating this, well, let me take one step back. So there are a few issues in our soy.w object. You know, so what I want you to visualize first is I'm just going to print soy.w below. So a couple of things that are going on here. Number one is on the soy.w, which is the one we brought in from NASS, we have this category called other counties. There is no shapefile for other counties. We don't even know what that means, right? We don't even know which counties were combined into this category for each one of the different years. So even if we wanted to plot whatever it's in other counties, we don't have a good way of doing that, at least not if we're putting this in a map, right? So the first point is if I want to use this column here that is called county from the soy.w, which came from NASS, with the name column of our Georgia Co data set that has the actual county name. So I'm basically using county name from both data sets to merge them. And then from one side, bring the NASS data, from the other side, bring in the shapefile or the vector of data and make them together in the same object. First off, other counties does not exist in Georgia_CO. So we have to remove that first. Secondly, if you notice here, let me come back to soy.w. Soy.w has all the names uppercase. And this is not going to match with the style that is coming from Georgia Co. That is the first letter uppercase, everything else lowercase. It's not going to match, right? So we first have to bring one of them to the same style as the other, and then do this merge for this to work. So now if we go back to the chunk that I was showing you, that's what we're doing here. So the first thing is I'm filtering where county is different than other counties. So some years it says other counties, other years it says other combined counties. So it has these two levels under that county column that we have to remove first. And we're doing that, removing that right here. So if you see before we did a filter that was equal to some value, now we're doing a filter that's different than. And the way that we code that is by using the exclamation point. Instead of double equal sign, we do exclamation equal sign. This means different. Okay. What I want to do first, and if you want to go ahead on your side, you can run this at once. I just want to go a little bit slow there and just, I'm going to add a hashtag right here. So I stop the flow right there. And I want to run from soy.w until the end of this filter. So remember, soy.w has 5,877. If I run this until this point and I print soy.w all, now I have a little bit less, right? So 5,499 records because I removed some where other counties and other combined counties were the name under that column, right? Okay, I'm gonna remove the pipe there so I'll allow that to connect to the next function. And now this next function here is I'm taking this county column and I'm using this function here, str to title, string to title. This function is coming from a package called string R. This package here is really, really handy whenever you're working with strings. We used this a couple of times already. If you remember, I think we used it to remove the comma. We used str_remove to remove the comma from that number, the production number last script. Here we're using str to title, as that function is basically going to rename our counties to title case, which means the first letter uppercase, everything else lowercase. So if you let that run and you print it, this should be your output. And now at this point, we have both the county column or the county names in the soy.w all and the county names in the Georgia County object follow the same naming convention. So now we can bring them together and merge them, which is what we're going to do here on the next step. Or I guess not, I guess maybe not quite yet. Now we're going to get the Georgia County object ready to go. So let's just give it the assigning symbol and type GACO. That's our object at this point. I just want to print this again just to remind you a couple things that we're going to do here. First off, this Georgia County object has 15 columns, 15 fields. We really don't need all of them. The only two that we need to keep to make what we want to make, which is combine these two, is the county name, which here is called name, and the geometry. That's all we need. We really don't care about anything else in this data set. So let's go ahead and do that select. So add a pipe here, hit return. Let's make sure we're getting select from dplyr. So you type dplyr : select. And then we want to keep that, again, here, the name of the column is name. So we want to keep name and geometry are the two things we want to keep from this. If you run that and you print it, now that's what you have. We have the name column and the geometry column. And just another quick workaround here is that if you see on our soy W all, the name of the column that has the county names is the column is called county, and here the column is called name. So we need to get one of those two to match the other. So I want to do that here on Georgia County W. So if you recall, on a select, you can also do a renaming on the fly. So I just want to call this county equals to name. So he's taking that name column and then renaming it to county. If you run this and you print it, now we have the county column with all the county names in title case, which is just the first letter uppercase, and we have the geometry. Whereas on the other data set, we have also county name. So on the one coming from NASS, we also have county name, we have year, and we have production, right? So now all is left for us to do is combine both of those objects into one, and then we're going to be able to do some plots. We're going to continue doing that on Wednesday because we are at the end of the hour here. So go ahead and make sure you save your script. So just click on save. You know what? Actually, our class ended at 10. I'm sorry. I keep thinking it's a full hour. And let me just open our attendance here so you can claim attendance for today. If you had to leave class at 10, you're welcome to claim your attendance as well. So attendance, January 29th. Okay, so I just opened that up. Please go ahead and claim your attendance. And we'll keep going and keep working on this next class period. Thanks, everyone. So Kumar, can you send me a Zoom link? Can you meet right now, right after class? Okay, so if you can send me a Zoom link, please do that, and I'll connect as soon as I get to my office.
I'll send you.